Now, I want to identify the period of this function and then sketch it from 0 to pi. Now, you should notice it's a tangent. Over here is a tangent graph. This is y equals tangent x. We have negative tangent 3 theta. Now, theta is x. You kind of think of it the same. They're just using theta instead of an x. Yeah. So we're using radians along here as your x value. So don't get confused when you see x or theta. They are very similar. So are you okay? It says from 0 to pi, so I put 0 to pi. Now, if you look at tangent, do you understand your asymptote normally for tangent is at pi over 2? You might want to write that down. And the next one is going to be at 3 pi over 2. Now, do you also notice the period? What is the period of this graph? Well, can you tell the period? Maybe I should write the word period instead of just p. Well, the period, can you tell? Well, if I'm going from pi over 2 to 3 pi over 2, that's a little hard to see the period. But can I just see this? If I go from 0 to pi over 2, and then from 0 to pi over 2, what's pi over 2 plus pi over 2? Pi. So can you tell in between each asymptote is the length of pi? Because you have pi over 2 and pi over 2. So what is the period? The period is pi, not 2 pi, like sine and cosine. So my period is pi. All right. But this one is 3 theta. So if I want to find my period on this one, I have to do something. Before, didn't we take 2 pi and divide by b? Now we're going to take pi and divide by b. So our period is going to be pi divided by our b, which is 3. Can we reduce that? No, pi over 3. So each space between each asymptote, right here, see it from here to here, is going to be a space of pi over 3. Between here and here is going to be a space of pi over 3, or an interval length of pi over 3. So if my period's pi over 3, my period here is pi. Now watch this. If my period's pi, remember I went pi over 2? Isn't pi over 2 half of pi? So what's half of pi over 3? Are you okay? That's pi over 6. So my first asymptote is always going to be half my period. So what's half of pi over 6? It's pi over 3. Sorry, half of pi, that is backwards. What's half of pi over 3? Pi over 6. So that's a little ugly, because I'm like, oh, okay, pi over 6. All right, that's, oh, crud. That's pi over 2. Oh, can I break this into 6? Can I break it into 6? Okay, is that halves? Right, that's pi over 2. I want pi over 6. So can I break this up into thirds here? Is that going to be pi over 6? So half of pi over 3 is pi over 6. Half of pi was pi over 2. So what I'm going to do here is I'm going to graph an asymptote at pi over 6. So if I know now this is my asymptote, when is my next asymptote going to appear? Well, if pi over 3 is my period, won't it appear at pi over 3 away from this? Now the question is pi over 3. How far away is pi over 3 from pi over 6? Sorry, a length of pi over 3 away from pi over 6. Well, what you want to do is you want to take pi over 6 and add pi over 3. Now, they have different denominators, don't they? So could I multiply top and bottom by 2, and I now have pi over 6 plus 2 pi over 6. What does that give me? 3 pi over 6, which is also what? Pi over 2. Man, it's terrible drawing. So what happened is, if I'm at pi over 6 and I add pi over 3, I am now at pi over 2. So there's my next asymptote. Now, can you add another pi over 3 for your next one? Or can you just see the pattern? I would hope you can see. Well, aren't I just going every 2? Now, is another one going to be right here? It's like, okay, I'll just put that there. I'm not going to worry too much about trying to kind of keep adding pi's over 3's. I'm just going to kind of keep the pattern going. Now, the next part of the question is, look at the graph. This is a negative tangent. So isn't a negative tangent going to be upside down? So from here, for the first pattern, normally it went like this, right? So won't it be flipped? Do you see how it's going to be like that? Can you kind of see that? Instead of going up, it's going to be going down. Instead of this graph right here going up like this, can you tell it's going to be going down like that? So it's going to go like this, hit right there, and back down. And then can we repeat it over and over until we finish our interval? Now, it's important, class, that you hit the middle there. See right there? That's an important hit spot. It always hits right between the asymptotes. That is, and if you don't do that, it'd be a big bad error. That's one of the most important spots for graphing this. How about this last little segment? Can you tell, isn't it just going to be from here to there?
Yeah.
So you kind of go down, asymptote, and approach. Ooh, that was ugly. Okay. So now you have, from 0 to pi, a picture of negative tangent 3 theta.